Okay, so we all know AI is changing the world, right? But it's got this dirty little secret. It is incredibly hungry for power. And that massive appetite is pushing us toward a very real, very physical wall. But what if there was a different way? A way to get all the power of AI without that crippling cost? Well, let's dive in. Right now, the AI industry is kind of stuck in what you might call a computing swamp. We just keep building bigger and bigger models that demand more and more brute force computation. And that's creating this massive, super inefficient drain on our energy grid.
And that really brings us to the big, looming question for this entire technology. I mean, we're seeing this absolutely explosive growth in what AI can do, but can we actually keep it up? Are we about to hit a physical and economic wall and just run out of road?
Now, this chart tells a really powerful story. That blue dotted line, that's the slow and steady march of hardware getting more efficient. But that steep red curve shooting upwards, that's the exponential energy demand from AI. That huge area between them is what we're calling the efficiency gap. And honestly, it's a massive, growing energy crisis in the making.
And to put a number on that gap, just look at this. The prediction is that by 2030, global data centers are going to be burning through 945 terawatt-hours of electricity a year. That's more than double what we use today. And yeah, you guessed it, the main reason is AI.
So the industry is at a crossroads, right? It's facing this fundamental choice. Do we keep doing things the old way and bake all our knowledge into these giant models, or do we try something new and bolt it on instead? On the left, you've got the way we do things now, fine-tuning. You take a huge model and you just cram it full of your private data, baking that knowledge right into the system. It works, for sure, but it's incredibly expensive, burns tons of energy, and you end up with a total black box. On the right, you have a totally new idea, the CHI architecture. Here, you keep your data separate in what they call an exocortex. You can think of it like a super efficient external brain that you can just bolt on to any AI model you want. And this diagram just lays it all out, doesn't it? The left side is the old way, this chaotic, tangled mess feeding into a hot, power-sucking GPU cluster to make one giant model. The right side is the CHI way. Data gets intelligently sorted and routed with total precision to specialized, efficient hardware. It's really the difference between using a blast furnace and a surgical laser.
All right, so let's dig into this solution. This CHI architecture, this exocortex, it represents a really fundamental shift. It's not just a new piece of software, it's a completely different way of thinking about data itself.
And the core idea here, the big shift, is something called teleology. You see, for decades, our computers have been obsessed with morphology. They ask, is this a PDF, a JPEG, a text file? CHI changes the question completely. It asks about the data's purpose. What is this data trying to do? Is it trying to express an idea, define a rule, or execute some kind of logic?
So here's how it works in practice. CHI basically atomizes any piece of data into three different jobs. First, the representational part, the intent of the data, that gets routed to a specialized neuroprocessing unit, or NPU. Second, you have the managerial part, the rules, the permissions, which is physically locked away in a secure M6 hardware core. And third, the computational part, the raw logic. That gets executed directly on an incredibly fast FPGA. It's about decoupling knowledge from the model and sending each piece to the absolute perfect tool for the job.
And splitting up knowledge like this, well, it's not just some clever engineering trick. It leads to a truly staggering, almost unbelievable leap in real-world performance.
But I know what you're thinking. A quantum leap. Okay, but what does that actually mean? How much faster, how much cheaper, how much more efficient are we really talking about here? Just take a look at these results. You don't even need to read the tiny text. The visual story is crystal clear. In every single metric, the CHI architecture, in blue, doesn't just beat the old fine-tuning method in red, it's not even in the same ballpark. We're talking about improvements of several orders of magnitude in energy, cost, and speed. And let's just park on that speed for a second. This system achieves a deterministic latency of just 60 nanoseconds. Not milliseconds, nanoseconds. That is a level of speed and predictability that moves us from just answering questions to powering real-time systems that we couldn't have even imagined before. The energy savings are honestly just as mind-blowing. Look at this chart. A single query with a fine-tuned model chugs over 6,000 joules of energy. With Kai, just 1/100th of a joule.
That is an efficiency gain of over 99.9%. It practically eliminates the energy costs for each query.
And this performance matrix just sums it all up, doesn't it? If you look at the chart, that tiny little red shape in the middle, that's the performance of traditional fine-tuning. That big blue shape that covers almost the entire chart, yeah, that's CHI. It's not just a little better at one thing, it is vastly superior across every single critical dimension.
Now, this level of hyper-efficiency, it's about more than just saving money on your electricity bill. This unlocks an entirely new way of doing business, where efficiency itself becomes the product.
Welcome to the idea of compute arbitrage. Instead of selling AI as a service, you sell the efficiency that your AI creates. You're basically selling the money you save your customers. And because those savings are so huge, there's more than enough profit to go around.
This chart makes it totally clear. Let's say a complex AI task costs a company $1 using the old method. With CHI, the actual cost to run that same task plummets to just 18 cents. So, the provider can then charge the customer 50 cents. What's the result? The customer saves 50%, a massive win, and the provider makes a 177% profit margin. It's a win-win. And the savings don't even stop there. Qi is built on something called the 1% storage paradox. It recognizes that 99% of the data in a normal file, like a PDF, is just formatting junk for human eyes. Qi strips all that away, storing only the pure 1% of logic a machine actually needs, and that just slashes storage and bandwidth costs.
But, the most profound thing about this technology might go beyond just the speed and the cost. By separating knowledge from the model, CHI makes AI something it has never really been before: reliable, auditable, and, truly trustworthy.
And this gives us 3 game-changing advantages. First, you get absolute data sovereignty, because your sensitive rules are physically locked away in a separate hardware core. Second, you get to eliminate AI hallucinations, because the facts are stored separately from the creative, language-generating part of the model. And third, you get perfect auditability, because every single decision can be traced back to the exact piece of data that triggered it.
So when you put it all together, this is really about the future of AI itself. It's a path to transform the technology, moving away from the current model of an unpredictable, energy-guzzling, probabilistic black box, and creating a new generation of AI that is a cool-running, trustworthy, deterministic precision instrument. And that changes everything.